Hello and welcome back to Mathletics with Sir Nawaz. Today we are going to start the chapter 7 from book 3, 8th edition, and it is about mensuration, the volume and surface area of pyramids, cones, sphere and composite shapes. In exercise 7a it is about the volume and surface area of pyramids. So as we have to complete one exercise in one video, so I will add the time steps and you can directly go to the required question. Let us start it without any delay. So before we jump to the question, remember that volume of a pyramid equals one third the product of base area and height, and there is no formula for the total surface area of a pyramid. So we will draw the net of that pyramid and then add up the areas of all surfaces. So now let us start the question number 1. Question number 1 states OABC is a triangular pyramid with base area of 15 centimeter square. Remember, a triangular pyramid can also be named a tetrahedron. Okay, we are given the base area of 15 centimeter square and a height of 4 centimeter, and we have to find the volume of triangular pyramid. And as we have to figure out the volume of pyramid, we must know there is a formula for the volume of pyramid as one third the product of base area times height, and both are given. Base area is 15 while the height of the pyramid is 4. So we will simplify it, and after I cancel 3 with 15 it will be 20 centimeter cube. That will be the volume of pyramid given in question 1. Now in question 2, OABCDEF is a hexagonal pyramid with a base area of 23 centimeter square and a height of 6 centimeter. Find the volume. So again we have to figure out the volume, and the formula for volume is still the same. It is one third the base area times height, and whatever the base is, if we are given the base area, then we will just replace the value of that is 23, and then height is 6. So after we simplify it will become 46 centimeter cube. So that is the question number 2. Now in question 3, OXYZ is a pyramid whose base is a right angled triangle with XY 7 meters, YZ 4 meters, given that the height of pyramid is 5 meter, and we have to find the volume again. So as we know, volume is one third the base area times height, but now we are not given the base area, but we are still given the dimensions of the base. As we can see the pyramid over here, the base in this case is right triangle XYZ, and we know how to find the area of a right triangle. It is, as it is base, so base area will be, it is 1 by 2 times the base multiplied to height, the base of triangle and height of triangle. The base of triangle and height of triangle are 4 and 7 respectively. So it will be 7 times 4 divided by 2, and that is 14 meter square. So that is the base area, and now we replace it in the formula for volume. So volume shall become one third the product of 14 and height was 5, so it is 70 divided by 3, and after we use calculator to calculate its value, it will be 23.33 meter cube, correct to 2 decimal places, or otherwise I can also write it as 23 whole 1 upon 3 in meter cubes. So that was the question number 3. Now in question 4, A pyramid with a triangular base has a volume of 50 centimeter cube. So we are given the volume of the pyramid with a triangular base. If the base and height of the triangular base are 5 centimeter and 8 centimeter respectively, find the height of the pyramid. So now we have to figure out the height of the pyramid, and we are given the volume of pyramid. As we are given the volume of pyramid, we will start with the volume definitely, and we know volume is 50 centimeter cube. As we know, the formula for volume is 1/3 the base area multiplied to height, and now it equals 50. As we know, the base of this pyramid is a triangular base, and the area of a triangle is definitely 1 by 2 times its base and height, and base and height of the triangular base were given 5 and 8 centimeters. So will be 5 multiplied to 8 and multiplied to the height of the pyramid represented with the capital H, and if it equals 50. Now we have to simplify it. I will cancel 2 with the 8, and here we are left with 20 divided by 3 multiplied to H is equal to 50, and when I move 20 upon 3 to the right hand side, so it will become 50 multiplied to 3 upon 20. So after we simplify, H shall become, I'm going to cancel out the 0, 15 divided by 2, and that is definitely 7.5 centimeters. So height of the pyramid is 7.5 centimeter for the question number 4. In question 5, the volume of square pyramid with a height of 12 meter. It is a square pyramid, which means that base of the pyramid is a square, and the height of the pyramid is given 12 meter while the volume is 100 meter cube. Find length of the square base. So first of all, as we are to find the length, suppose it is represented with small l of its base, and we are given again the volume, which is 100 meter cube. As we know, the volume of a pyramid is 1/3 the base area, and as we know, the base is a square with length l, so it will be l square multiplied to the height of the pyramid h, and this shall equal 100. So now we start simplifying it. We know l is unknown and the height of pyramid is 12, and I will first move the 3 to the right hand side, so it will become l square multiplied to 12 equals 100 times 3. So l square must become 300 divided by 12, and when I simplify this one, the value for the square of length, it becomes 225. So as we need the length, it will be square root of both sides, and length shall become 5 meters. So length of the square base is 5 meters in the question number 5. In question number 6, OWXYZ is a rectangular pyramid where WX is 66 centimeter, XY is 32 centimeter. Given that the slant heights OA and OB of the pyramids are 56 and 63 respectively, draw its net and hence find the total surface area. As we already know that we cannot find total surface area with any formula, but we need to draw the net of that given pyramid. So in order to draw the net of this pyramid, first of all we will draw the base. So as we know, it is a rectangular pyramid, so its base is a rectangle with the two sides 66 and 32 centimeters. So here it is the base of this pyramid. Its vertices are W, X, Y and Z. Now we need to draw the slant surfaces which are all triangles. So we will start with the right one, which have a height of 63 centimeter. So we'll draw it over here. So the shape on the left hand side will also be the same, because the two shapes on the opposite sides are equal. And similarly, now we need to draw the triangle over here, the side facing us, and definitely there is a congruent triangle opposite to it as well. And all of these vertices are O. So it completes the net, but we still need to mention the dimensions of this one. As we know, this base is 66 centimeters and here it is also 66 centimeters. This one is 32 centimeters and here it is also 32 centimeters. And the height of this triangle OXY, it is 63 centimeter, as we know that this point is B and it was given that OB is 63 centimeter, and OA, as we can see, it is located over here. Here is the point A and we know OA was 56 centimeter. So here it is also 56 centimeter and this one is definitely 63 centimeters. Now, in order to calculate the areas of all these shapes, first remember that the triangle OXY is congruent to the triangle opposite to it, which is OWZ. OWZ, so that their areas are equal. And in the similar manner, the triangle OXW is congruent to triangle OZY and their areas must also equal. Now we start finding the areas and we will start with the area of base. So total surface area equals first base area, which is a rectangle with the side 66 and 32. So this is the base area plus 2 times the area of triangle OXY. As we know, the triangle OXY and OWZ are congruent. They have same area. So that is why I have written 2 times. As it is a triangle, so the area of triangle, it is 1 by 2 base into height. And what is the base of this triangle OXY? It is 32 and height is 63. So 32 times 63. In the similar manner, as we know, OXW is congruent to OZY, so they two have same area, so it will be 2 times 1 by 2 into, now the base of this triangle is 66 while the height of the triangle is 56. And now the remaining simplification definitely need a calculator. We'll cancel out whatever is cancelable and then we will use calculator to calculate the value of final answer. And it equals 7,824, and the dimensions were in centimeters, so area will be in centimeter square. So this is the total surface area of given pyramid. It was question number 6. Here is the question number 7, and it states find the order of rotational symmetry of each of the following solids. As we can see in A part, the shape given is a square pyramid. As we can see that all of its four sides are equal, so it must be a square pyramid, and the order of rotational symmetry of a solid basically depends on its base. As its base is a square, so we will see that what is the order of rotational symmetry of a square, and that is actually 4. So if the order of rotational symmetry of a square is 4, then definitely the order of rotational symmetry of this solid is also 4. The order of rotational symmetry basically depends on the base in case of a pyramid and in case of a cone as well. In B part, if we see, it is again a pyramid with a six-sided base now, and as we see all six sides are equal, so it must be a hexagon base, hexagonal pyramid. So as a hexagon has six sides, so order of rotational symmetry of hexagon is also 6, and same is the order of rotational symmetry for a hexagonal pyramid. So the order of rotational symmetry for the first solid is 4, and order of rotational symmetry of the second solid is 6, and that definitely depends on its base. Whatever the order of rotational symmetry of the base is, that is basically the order of rotational symmetry of the pyramid. In question number 8, it is stated that for the following solids, state the number of planes of symmetry and axes of rotational symmetry. And in A part, as we see, it is a regular tetrahedron. And what is a regular tetrahedron? Basically, it is a shape whose all six edges are same. All edges are same. I mean that these sides are all equal. So it will be a regular tetrahedron. Now, in order to find the planes of symmetry for this regular tetrahedron, there are three vertical planes of symmetry and there are three inclined planes of symmetry. So there are basically 6 planes of symmetry for the tetrahedron. 3 vertical plane of symmetry through each vertex and 3 inclined plane of symmetry through the midpoint of the each edge. Then axis of rotational symmetry, and as it is a tetrahedron with all sides equal and there are 4 vertex, so definitely there are 4 axes of rotational symmetry. Now in B part, as we see, it is a square pyramid, and in square again the 4 sides of the base are definitely equal. So the planes of symmetry, there will be 4 planes of symmetry, and the all 4 planes of symmetry are vertical. 4 planes of symmetry, and 2 planes of symmetry are basically passing through the midpoint of sides, and the other 2 are along the diagonals, the other 2 diagonals. So there are 4 planes of symmetry. And about axis of rotational symmetry, it is only one axis of rotational symmetry which is basically passing through the center of base of this pyramid. In question 9, a glass paperweight is in the shape of a solid pyramid with a square base of length 6 centimeter and a height of 7 centimeter. Given that the density of the glass is 3.1 gram per centimeter cube, find the mass of 4 identical paperweights. So definitely if it is the mass of 4 identical paperweights, I can say it is 4 times the mass of one paperweights. And in order to find the mass of one paperweight, as we can see that we are given the dimensions of that pyramid, and through that we can find the volume. So we will reshape this formula. It will become mass equals volume multiplied to density, and then we will multiply it with the 4 in order to get the mass of 4 identical paperweights. So first of all, let us find the volume, and volume for this pyramid will be 1 by 3 times base area, and as we see the base is a square base of length 6, so I can say it is 6 square multiplied to the height which is 7, and when we simplify it will be 1 by 3 times 36 times 7 and 84 centimeter cube. So that is the volume of one paperweight. So what will be the mass of one paperweight? It will be 84 multiplied to 3.1 gram per centimeter cube. So that will be the mass in grams. 84 times 3.1 equals 260.4 in grams. So that is the mass of one paperweight, and as we need to figure out the mass of 4 paperweights, so it will be 4 times 260.4 gram, and that shall become 1041.6 grams. So that is the answer to this question, the mass of 4 identical paperweights. So this was the question number 9. Now in question 10, VABCD is a pyramid with a rectangular base of sides 15 by 9 centimeter. Given that the slant height VQ of the pyramid is 16 centimeter, find its height and volume of the pyramid. So first, in order to figure out the height of the pyramid, let me first draw the height over here. This is the vertical height, and we know it is passing through the midpoint of the diagonal. So as we see, like this side AB is 15 centimeter. So if I move it in the middle of the shape, so it is definitely passing through the midpoint of this 15 centimeter, so it must be 7.5 centimeter on each side. Now as we see, 16 centimeter becomes a hypotenuse of this right triangle, and if height is represented by h, so we can definitely apply the Pythagorean identity to find the value of height. This triangle with one side 16, one 7.5, and third h, so it will become h square plus 7.5 square equals 16 square, and h square equals 16 square minus 7.5 square, and then we will figure out the value of h with the help of calculator. So h becomes 14.3 centimeter correct to one decimal place. So that was the first one. Now in order to figure out the volume of a pyramid, we know it is volume equals 1/3 the base area into height, and as we know it is a rectangular base pyramid, so the area of rectangle is definitely length multiplied to width, so it will be 15 times 9, and then we multiply it with the height, which was 14.3, and again use calculator to figure out the value of volume, which now becomes 636 centimeter cube. So this was the question number 10. Now in question 11, stated that a solid pentagonal pyramid has a mass of 500 gram. It is made of a material with a density of 6 gram per centimeter cube. Given that the base area of the pyramid is 30 centimeter square, find its height. So as we know, we can use the volume for the height. Yeah, we can say that volume equals 1 upon 3 times base area times height. So if we need to figure out the height, we must know the value of volume as well as the base area. We are already given the base area, which is 30, but we need volume. And as we are given mass and density, so we know density equals mass divided by volume. And if I need volume, I can rearrange it to write volume equals mass over density. So I can say that mass over density equals 1 upon 3 into base area into height. So as we have mass and density, we can just replace the values over here. Mass was 500, density was 6, equals 1 upon 3 times the base area was 30 and multiplied to height h. Now as we see, 500 divided by 6 is 83.3 equals, when I cancel it out, it becomes 10h, and as we need the value of h, so I can divide 10 on both sides in order to cancel the 10 over here. So we are left with the h is equal to 8.33 and in centimeters. So that is the value of height of that pentagonal pyramid. Now in question 12, VPQRS is a rectangular pyramid with a volume of 100 centimeter cube. We are given the volume and it is stated that it is a rectangular pyramid, so its base is a rectangle. Suggest a possible height of the pyramid and the corresponding dimensions of the rectangular base, as it is mentioned open over here. So in open question, we are to suggest some value and then calculate the rest of values corresponding to that. Here it is stated that suggest a possible height. So we will start with suggesting a possible value of height, but first let us deal with the volume, as it is known that volume equals 100 centimeter cube, and we know volume of a pyramid is 1/3 the base area into height, so it equals 100, and if I multiply 3 to both sides, it will be base area multiplied to height is equal to 300. Now here we suggest a possible value of height, and it can be any value, but a value where the calculations remain easy. Like if I suppose that h is equal to 6 centimeters, suppose it can be 5 centimeters, 6 centimeter, 10 centimeter, any value. So the base area multiplied to 6 equals 300, and if I divide 6 on both sides in order to cancel 6 on left, base area becomes 50 centimeters square. So as base area is 50 centimeter square and it was a rectangular base. So we are to see any two values whose product is 50, like if it is 5 times 10. So these are definitely its length and breadth. So corresponding to the height, like if height is equal to 6 centimeter, then length is equal to 5 centimeter or 10 centimeter, and the breadth is equal to 10 centimeter or 5 centimeter respectively. So this was an open question, question number 12. Now in order to solve the question number 13, it states VPQRS is a pyramid with a rectangular base of sides 10 centimeter by 8 centimeter. Given that the volume of the pyramid is 180 centimeter cube, find its height. So we can easily find its height first, as volume is given and we know volume is 1/3 the base area. Here it is a rectangular base with the sides 10 and 8, so I can directly write it as 10 times 8 times height, which is unknown, and this equals 180 because it was the volume. Now in order to figure out the value of height h, the divisor 3 will multiply to the right hand side, 180 times 3, and the multiplicand 10 and 8 will divide on right hand side, which is actually 80. So after we get help from the calculator, the value of height becomes 6.75 centimeter. So this is the value of height as mentioned over here in the diagram, 6.75 centimeter. Now in order to calculate the total surface area, definitely we need to draw its net, as well as we need to find the slant heights, because it is a rectangular base and there will be two slant sides, one over here passing through the midpoint of side QR and other over here passing to the midpoint of side PQ with the 10 centimeter. And for that, first we will draw a line parallel to PQ over here. As we know, PQ was 10 centimeters, so each side of this will be definitely 5. So we can directly find the first slant height over here with the help of Pythagorean theorem, because we are to find the uh, hypotenuse of this triangle. So it will become 5 square plus 6.75 square. That will be the square of its hypotenuse. And as we need the value of hypotenuse, so just square root both sides, and this will be one of the slant heights. So with the help of a calculator, it becomes 8.4 centimeter. Now in order to figure out the second slant height over here, we will first draw a side over here which is parallel to QR. As we know, QR was 8 centimeter, so each part of this will become 4 centimeter and 4 centimeter. Again, the slant height over here is again the hypotenuse of a right triangle with the other two sides 4 and 6.75. So again, hypotenuse square shall equal its base, which is 4 now, 4 square, plus its height, which is 6.75, and then square root both sides, and that will give us the second slant height. And let us calculate it with the help of a calculator. It is 7.85 centimeters. So these two are the slant heights over here. This one was 8.4 centimeter, and this slant height over here is 7.85 centimeter. Now in order to calculate the total surface area, let us draw its net. And we know it was a rectangle base pyramid. So first let us draw its base, which is a rectangle. Here is the base PQRS. This side is PQR over here and S over here. Now we draw the slanted faces, and they are all triangles. So here is the one triangular face and a congruent face opposite to it. And the slant face so this is the net of this shape, and the dimensions over here, this was 10 and this was also 10. Here it is 8 centimeter and this is also 8 centimeter, and this slant height, the height of this triangle, it was 8.4, and same was the height for this triangle because these two are the congruent triangles. It is also 8.4, and in the similar manner this slant height was 7.85, and same was the height of upper triangle because these two are also congruent triangles. This is also 7.85. Now we start calculating its surface area. So total surface area shall become the area of base, which is definitely 8 times 10. Then as we know, these two triangles are congruent, so it will be 2 times the area of one triangle, which is 1 by 2 times 8 into 8.4. Then again these two triangles over here are also congruent, so its area will be 2 times 1 by 2 into its sides 10 times 7.85. Now again we use calculator to simplify this and cancel 2 over here, and this is 225.7 centimeter square. So this is the total surface area of the given pyramid. This was question number 13. Now we are starting question 15. We have skipped the question 14 because it was exactly similar to the question number 13. In question 15, it states a pyramid has a square base of length 8.4 meters, 4.8 meters, and a total surface area of 85 meters square. Find volume of the pyramid. Again, in order to find the volume of the pyramid, it will be volume equals 1 upon 3 times the base area multiplied to its height. We can simply find the base area because we have a length of the square, but in order to find the height of the square we will use the total surface area, and for that we need a rough diagram of the pyramid and then its net as well. So let us first draw a pyramid over here. So this is a pyramid with a square base of side 4.8 meters. This side is 4.8 meters and all other sides of the base are also 4.8 meters. Now we are to find its vertical height, and we are given the total surface area. In order to find the in order to draw its net, we know it is a square base pyramid, so I will draw a small net over here. First a square base and then the 4 congruent triangles on each side. So So this is the net of the pyramid, and its base is 4.8 meters, and its height of its triangle, let's suppose that it is represented with small h. So as we know, the total surface area, in case it will be the area of base, which is 4.8 square, plus the area of four congruent triangles, and there are four congruent triangles, so I will write it as 4 times 1 by 2 into base times height, and base is definitely 4.8, and the slant height is not unknown, so I will name it as small h. Now it equals, as we know, the total surface area was 85, so right hand side is 85. Now we need simplification of this, and 4.8 square is 23.04, plus it is 2 times 4.8, so it will be 9.6 h. It equals 85. Now we subtract 23.04 on both sides, minus 23.04, so that we are left with 9.6 h equals 85 minus 23.04 is 61.96, and as we need the value of h, it will be 96. So 9.6 divided on both sides will give us h is equal to 6.45 centimeters. So this is the value of slant height. This is not the height. So as we know, the slant height is located over here. This one is 6.45, and as this side over here, it is 4.8, and when I draw the vertical height represented by the black side, it passes through the midpoint of this side, splitting 4.8 into 2.4 and 2.4. Now if we want to find the height of this pyramid, it is basically height of the right triangle, so we can use the Pythagorean theorem in order to find the height over here, and the hypotenuse of this triangle is 6.45 while base is 2.4, so I will write it as capital H. Now h square plus 2.4 square equals 6.45 square, and h equals 6.45 square minus 2.4 square, and then we square root both sides, and that will give us the height of the pyramid. It is 5.98 centimeter, so that is height of the pyramid. So now we can figure out the value of volume. It will be equal to 1 upon 3 into base area, it will be 4.8 square, multiplied to the height, which was 5.98, and again with the help of calculator we will figure out the value of volume, that it is 46 centimeter cube. So that is the volume of the pyramid. So this was the last question of this exercise. There are some other questions which we are not going to try, because that is enough for practicing the volume and surface area and symmetry of the pyramids. So see you in the next video with the next exercise.